Also, thank you for the organizers doing it for 20 years. It's amazing to build a community, I have to say that, and I'm really impressed with that. So I've attended this in the years past, and I'm just really happy to see that it's growing so much. About myself, I'm a principal solutions architect for a company called Upboun. We're one of the primary developers of the Crossplane project. I have a very long line of experience doing systems engineering, cloud engineering, and I joined Upboun because I really felt that this was kind of the platform of the future. So I've been working there for 3 years now, and we're going to talk about it. The first thing, what is Crossplane? And the last talk was amazing because it kind of set up where we're coming from, right? Like Kubernetes has started to win in the enterprise. It's a massive, and Jacopo talked a little bit about things like CRDs, all the security around it. So what Crossplane is it takes Kubernetes and it allows you to manage anything with it, right? So we're talking about S3 buckets, Salesforce users, anything at all. Right, so this is kind of, we're leveraging that Kubernetes is becoming the standard platform, and we're using everything underneath it. And it's really emerging as probably one of the strongest open source projects in this field of platform engineering. And just to let you know, we are a CNCF project. They mentioned that, so we're licensed under Apache 2.0. We are a candidate for graduation, right? So I think we're close to 9,000 Google stars right now. We have 50 public adopters of like large corporations that use it, who admit publicly to it. And I just wanted to put like, you know, we have, you are here in the universe, in the CNCF landscape, we're up there, one of the larger projects, but we're up there under provisioning. Yeah, so that's what it is. So Upboun doesn't own the trademarks, like as all CNCF projects, the CNCF actually owns the trademarks. We have to have a governing board, we have to have open source. There's security standards that all CNCF projects need to adhere to, and you know, we talked about it before, like are you signing your builds, are you doing things like that, do you have trusted commits? So that's all handled by the CNCF. So the first thing is, we talk about IAC and platform wars, and the question is like, why would you use Crossplane, right? Like why would you use it over something like a home-built Terraform or Pulumi or CloudFormation? And really the reason I think so is that the architecture of Crossplane is really, really good. We have a core engine that runs, that does some basic things, and then we extend the system using things, providers and functions, right? So like we have a core that's actually shrinking, we're pulling things out of it. The next thing is, really important thing for platform engineers, and I spent a lot of time doing infrastructure, is that a lot of times the API we give to users is an afterthought. Right? Like we give them like a commit a JSON file to Git and we'll provision your infrastructure for you. In Crossplane, we leverage Kubernetes CRDs to define new APIs. So it's more suited towards platform engineering and delivering APIs to your customers who are like consuming it via something like ArgoCD or Flux. Controllers run continuously, so any drift will get corrected automatically. And this is a new thing. Crossplane until about November of last year kind of had a very fixed engine for creating desired state, and it wasn't that great. We released something in November of last year that basically, it's almost like lambdas for infrastructure, and we'll talk about it later on, but it lets you define what you want to create in almost any programming language. And this makes Crossplane super powerful right now because you could use Python or Go templating or use some functions that are already available. KCL, which is a growing language, just came out. And the other thing that Crossplane is really good, because we're built on Kubernetes, and we talked about the security there, all those things, right? We natively take advantage of all of that, right? Like your container scanning, any controls you have on the Kubernetes API, anything you define in Crossplane automatically could take advantage of those. So you don't need a whole other security infrastructure to control your infrastructure provisioning versus what you're doing for all your applications. And finally, day two operations. Hopefully we'll have time to touch on this in this talk, but we could do things like have Prometheus metrics on every single thing that we monitor. So like you can provision an S3 bucket and then see how long that takes to create. And I think this is something that really differentiates Kubernetes-based solutions versus other things, is that we could put Prometheus metrics on almost everything, right? So you can have observability across thousands of resources on dozens of clusters in a central place. So hopefully that's good. We're going to have really talk here. It's going to be somewhat technical, and hopefully I'm tethering my phone so we could do some demos, but we'll see. We're going to talk about just here what we're going to cover. So let's go. The first thing is that we are built on Kubernetes, right? So this is something important to understand, and the core concept of really Kubernetes, one, is the API server, right? This is one of the key differentiators of Kubernetes. It's a consistent way of addressing clusters, right? So what I have here is an example of just some things you can come via the command line, CI/CD systems like Flux and Argo. There's also things like Backstage or whatever. Anything that could speak to the Kubernetes API could talk to Crossplane. And an important thing here is with the API server, it's a single point for authorization and authentication, right? So a lot of people have security policies. If you're using something like Caverno, you could block that ingress in one point, right? So your controls of your infrastructure can be a single point of control, and you're probably already doing things today. We have a lot of people integrating this with OIDC, so you could give temporary access to system administrators using your existing OIDC mechanisms and things like that. The next thing is everything at Crossplane runs on Kubernetes, so we use things like pods, we use service accounts, services, conversion webhooks. So all those things we take advantage of, and it makes it a very powerful framework. So let's talk about the first one, right? We're going to start from the first basic principle, and that is a managed resource. So what Crossplane does is inside the Kubernetes API server, we map every single object that we want to create as a Kubernetes CRD. So what does that mean? So what we're going to do here is we're going to say we want to provision a bucket in S3 in AWS. And how do we do that in the Kubernetes native way? What we do is we create an object in Kubernetes that is a high fidelity mapping of what is in AWS, right? And so what that means is, and there's a couple seconds delay here when I click, every version is a Kubernetes object. We could add all kinds of metadata to it. So we have a lot of companies that add automatically security tags, labels, and annotations so that they could query a cluster and say, who's asked for this? And then finally, we have this thing called a high fidelity mapping, right? So if I click on this link here, and I will put the updated version of the slides up there, you could see basically everything that you could provision in an AWS bucket is available, right? So what a high fidelity mapping is, every single thing that's in AWS, and there's over 1,000 things you can configure in AWS alone, and both Google and Azure have 700 to 900 each. Every single one of those has a Kubernetes object that's mapped to it. All right, let's try creating one. And now we're going to see if the demo works. This will take about 30 seconds. Okay. So what we did here is I just applied it to the cluster. We're not writing a shell script, right? What I do is when I apply something to the cluster, it sets something over to the API server and it applies it. And then what happens is the controllers that are actually provisioning this have a watch and they wait for it. And this should take, we'll see how the Wi-Fi works here, maybe 30 to 40 seconds that it's going to go and provision it. And then what happens here is every single managed resource in Crossplane is managed individually. Like, so it's not like, so we're done now, right? So it took 30 seconds, it went and provisioned it. So, and that's it, we're done. Let's see. And what we could do is we can examine this now. And can folks see this? All right, let me do something better here. All right. So the first thing you could see is that every has conditions, right? Every single object in Crossplane has conditions, so we could actually see when the object was synced, when it went out of sync, and when it's ready. So when you're provisioning something like an RDS database, it could take 10, 12 minutes. You could actually monitor it here. We have something called, if you're used to Kubernetes, the standard Kubernetes API has a spec and a status, right? So the spec is your desired state, so that's what we asked for. And when we come back with a status, it comes back with all the things that come back from AWS, right? So this is for every single object, and we could use this with other programs. We could use it in compositions. So that is the core of Crossplane, right? We provision an object using the Kubernetes API, and we can get very rich information about that object. And this is refreshed continually, right? So you could actually set the polling because there can be times that you hit your APIs pretty hard. So we usually default to drift detection about an hour after it's up. But that is the core concept of Crossplane. All right. The next thing is how do we actually do this work, right? And that is the province of providers, right? So providers are controllers that run, that actually go talk to the backend. So what happens if you've ever used Kubernetes, if you don't know how Kubernetes runs, if you're used to other systems, a lot of times when you're provisioning infrastructure, you're like running a shell script and has a direct connection, and then you wait for an error code to come back or something. The way the Kubernetes API server works, it's asynchronous. It's almost like it's on two sides, right? You speak to one side of the Kubernetes API server saying, hey, give me this or give me the stat of this. And on the other side, these controllers do something called watches, right? So they watch for changes. The API server in Kubernetes handles things like updates, deletes, and creates. It's not something you have to think about. And it handles that at scale. So what you have to do is your controllers, just when they come up, they say, I want to manage buckets, so I'm going to watch this API endpoint, and if there's any changes that somebody asks for, I'm going to automatically provision it. So that's exactly what happens. They run forever. And we just had a blog that came out like a day ago that I put here that Akamai just wrote their own controller to basically manage almost all their internal infrastructure using Crossplane. And they made custom logic in it, but they're basically using this to manage hundreds of thousands of Ceph buckets across the world, right? So we're starting to see people do massive scalability things with this. And that's one of the cool things is because I didn't put in this slide, but all our controllers are built upon controller runtime, all the core Kubernetes libraries. And we put layers on top of it, but if you could write a Crossplane controller, which most people don't need to do, you have a deep understanding of how to write any Kubernetes controller. Right, so it's like a 20% addition to standard Kubernetes controllers. So what we're seeing a lot of our most advanced customers doing is writing their own controllers. Instead of doing things like, I'm going to write a CI pipeline, they just write a controller to orchestrate all the work. All right, how are we doing time? 15 minutes in? All right. I'm just going to put this really quickly. You can write controllers. We could also automatically generate providers via something called Upjet. And this is very efficient because we actually don't use Terraform. We actually bypass it and actually talk to the logic in the backends, and we could get very high scalability for this. And it's usually, it's very fast to write new providers. So we have very good coverage and it's growing. Our main cloud providers we have hundreds of APIs for every single one, and we're getting 2 or 3 new providers a week, it seems nowadays. All right. So that demo that I did before, I'm just going to put these at the end. So in the slide deck that I'm going to upload, I actually have QR codes for every single one of my demos here, so you can go and try these out yourself. So the next concept I want to talk about is composition. So we talked about managing one object, right? And how does that get done? Now the question is, you're a cloud architect, you're a solutions engineer, and you need to deploy things like an entire EKS cluster. I need to configure a VPC with peering, right? I need to do complex things. And how do you do that in Crossplane? I'm going to talk about our concepts, but the first thing I want to talk about is just how we think about it, right? So let's say that you're running a restaurant, right? And how does that work? Well, we know that you have a menu, and those are things that you offer other people. And when people order things, you have a set of recipes that you've worked on that you know work. And you combine the ingredients as part of that, and you create a meal, right? And when someone comes in to order, they order off the menu, and then you create a meal for them, and they get that, right? So we're going to talk about how those concepts match to Crossplane because we're getting into technical jargon, and I don't want to confuse folks. So the first thing is our menu are resource definitions, and you'll see us call them XRDs, right? So you'll see XRD, and all you have to think about is that's a menu. Right, so what you're doing as a platform engineer, you're defining menu items for people to consume, right? That's the first part. So think about this now, you're not infrastructure folks who focus on the code first, you're thinking, what's my API? And then the platform engineers then create the composition, right? They're saying, when someone asks for this, how am I going to create it? That's called the composition, and the thing that's generated the meal is a composite, right? So you see lots of C words that start with C, composite. I don't want folks to get confused. Just think about, use this slide to get yourself familiar with it. And then finally, a claim. So a claim is a Kubernetes term that we use that's like attached to an object in the cluster that say you're going to use it like a physical disk. In this case, when a user creates a claim, what they're saying is that I own this composite resource that was created. Okay? All right. So how do we define those menu items, right? How do we make those? And the way we do is with CRDs. So he talked a little bit about before how CRDs are starting to become standardized and people are building platforms on top of them. What we're seeing is Kubernetes is becoming increasingly dominant at these kind of internal workloads. So what we have here is, this looks like the bucket example from before, but it's not. It's similar enough, but this is something you as a platform team create, right? Like you're gonna say, I'm gonna make something, and it's gonna be native Kubernetes, right? So when you do kubectl, you could say, get me all the Postgres instances on this cluster that are being managed. So this is something that you create. The other thing too is he talked about secret rotation. You actually define what secrets come back. And these secrets are rotated. Like, so when you create a managed resource, and if it has secrets like a kubeconfig file, and those get rotated, Crossplane will automatically deliver those back to you in the form of a secret. And you as a platform API owner could say, this is the parts of the secret that I expose to my end users. So when they ask for an EKS cluster, they could get a kubeconfig in their own namespace that gets rotated. And finally, the way you define CRDs, and is defined via OpenAPI, right? So if you've looked at Kubernetes, we know we have giant walls of YAML, right, that are there. We define everything as OpenAPI, and I'll show you that in the next slide. You could see here we define instance type, right? So we have an enum. You could say, so when you're defining your API, you could say, this is going to be a small, medium, or large server. And then your platform engineer is going to map that to instance types that are specific to like AWS or Azure. You could set integers, regions, and like things like arrays, like that they could provide a list of arrays. So we talked a little bit about this. Because you're defining native Kubernetes things, all the things in Kubernetes today, like Kyverno or your OIDC controls on your API server automatically apply to this. So you can secure it, you could limit it, you could say, you could put controls in here in this file itself, or you could have external webhooks like Gatekeeper actually control this. So when someone asks for something that they're not allowed to, you could reject it just using the tools you already have today. All right. Let's see if we could demonstrate a composition. And I'm not going to let this run all the way, but let's, what I'm going to do here is I'm going to create a network, right? So this is a VPC, a network. And what I'm going to do, give me a second here. So we know when we're creating a VPC network, we want to have VPC subnets. Let's make this. So what we're doing here is, I'm like the font a tiny bit smaller. So in our standard network, and this is going to take a couple minutes, but I'm using a tool called Trace. Right, so we have a lot of developer experience tools around this, and what Trace does is it goes and looks at those compositions and it dives into it and it queries in real time what the status of those resources are, right? So you could do this via Trace, or this can be exposed up through your Prometheus metrics or whatever, but you can monitor here. And what you're seeing here is that you see how reference resources are not ready. So some tools like Terraform automatically create a graph in advance, but Kubernetes is a little more asynchronous. So things like the route table won't be created until a VPC ID exists. Right, so it's a little more loose in terms of how a graph of resources is created. And we do have controls around this, especially in terms of like deletion ordering, but just that's a significant difference about how it works. So we're just gonna let this run. So this is basically a composition, right? So a user orders a network, and let me go here, right? And all they're asking for is the ID in the region, right? That's the API contract you give to them, because we know when infrastructure teams don't want to give too much control to networks, and on the back end, you're handling the subnet creation, how things are working, who's allowed to use it, if there's any peering contracts or anything like that. So we'll let this takes a couple of minutes, especially over my phone, but we will let that provision. So that's what a composition is, right? Like, okay. It's just a set of managed resources, and in this case we're doing a network. We actually have a cluster one that takes about 20 minutes to provision, so we're not going to, in the interest of time, we're not going to provision it here. Let's see if that's there. Okay. Yeah, almost everything's ready now. Now we can try spinning up our EKS cluster too while it's going. All right. All right, let's get back. So we know now, okay, so let's talk about our foundations. We create one resource, right? And we saw that compositions are multiple resources, right? So the question is, how do you actually do that? in Crossplane, right? Like actually, when I created that network, how did that actually all come together? How does it know what region to put it in? And you can see here in the XR that we put all these things together, and then at the other end, once we create these resources, they go to whatever provider to provision them. And this is one of the coolest new features of Crossplane that I think is really differentiating, and these are functions, right? So we used to have a monolithic engine inside of Crossplane that was called patch and transform, and it was kind of almost like a little bit of like customize or JSON patching in Kubernetes, and it was okay, but it wasn't great. A lot of people were working around it with like Helm and other things. Functions came out in November 2023, and they came out way better than I thought they would. They're basically like GitHub steps, right? So what you do here is, in your composition, you basically have a series of steps where you're calling a function, right? And the functions run as a service. They're almost like lambdas that run in the cluster. And what you could do is you could run as many steps as you want, right? And at the end of all those steps, you spit out all those desired states. I want a bucket, I want a VPC, I want a subnet, right? That's what comes at the end of it. So you look at some other programming languages, it's like you put everything in Python or TypeScript or something like that. This is a little different. It's much more lightweight. It's more like a Lambda. What you're just doing is creating a desired state, and you don't care about the provisioning because of the architecture of Crossplane. The providers care about that, right? That's the difference. So, one second here. And I have a couple things here. I have, we're using a Go template here, and then we use some validation at the next step. We have people who are doing things like adding standard labels. There are all kinds of functions. We have a very fast-growing ecosystem. And the way it works is like this, right? Crossplane sends it to the first function. The first time you call this, there's nothing, right? And the first function structures it. It says, create me a bucket. And then it passes that on to the next few functions. And at the end of it, so this is like Unix pipes, right? If you've ever used Unix pipes, this is something very similar to it, the concept. Let me see if I could go find a good... So this example here, so if I cat my JSON, right, I just have a JSON. And what I do is I could pipe it and add a label to it. Like let's say I wanted to dynamically add labels to everything that you have JSON. In Unix way, what you do is if I cat my text file, and I'll make this a little bigger for everybody, and I have this in another slide, we're just using JQ. So you could use JQ to configure things, and that's how functions work. You just take the input in, it's almost like a pipe, a Unix pipe, you mutate the data, and then you spit out the other end. The way functions work is a little more complicated, but this is the core concept of it. Like the internal of Crossplane's engine is very much like a series of Unix pipes. Okay. So, and the reason we did this is we didn't want to build another DSL, support complex logic, and one of the biggest things for Crossplane is having massive scalability. Like we're talking about managing hundreds of thousands and millions of objects. And this is even some conditions where providers like monolithic Kubernetes controllers don't work really well because it's very hard to shard them. Functions work as lambdas, and we could scale them incredibly. We could run 100 functions. We could just replicate them. So it's very highly scalable. And the other thing too is functions are Docker containers. Like everything in Crossplane is either OCI images or YAML. So they're very easy to publish them, to share them, and to reuse them. And this is the example I had before. You just pipe this through JQ, and then you pipe it out. So functions are very easy to write. Like even in Go, you can write a lot of functions in less than 100 lines of code. What you get you get context. Right, so that is extra data. Like if you're observing external systems, you could put that into the function. You could say, let's say you have existing infrastructure. You could put that into the context and have it look at it. The observed state, like if you remember when we looked at that bucket, we had the ARN of it, when it was created, what region it's in. That's available to the function, and then the desired state from previous steps. Right, so your function, and all your function gets is a JSON map like that, right? So it doesn't have to care about the scheme or anything. So if you could write like Python and modify a map, you could write a function, right? It's very easy to write. The way functions work internally, we talk about that Crossplane depends on Kubernetes quite a bit. Functions run as a service. So what happens is when you install a function, it runs a Docker image, and then that's backed by a Kubernetes service, right? So we could have a dozen copies of one function that are behind a service. And the way Crossplane works is it sends a standard message, which is a gRPC, but once you get through the SDK, it just looks like a map, and then you send that back. That's it, right? So most SDKs present it to you as a function writer. You're just going to get a map, and the SDK handles the gRPC stuff, converting the data, listening on that port. So all you have to do as a function writer is just say, when I get this map, spit it back with new information. So functions can be very easy to write. And you can stack them, write them in any language because we're using gRPC. It doesn't matter what you're writing them in. All right. And where are we at here? We're getting close on time, so I'm not going to do a demo here. I have the link here, but basically what we have is another one using Go templating. So in this example of a function, I'm using Go templating, right? So if you use Helm, you're used to that. And we're using that to create, let's see here. We're using that to create the IAM self-trust rule. And what I mean by an IAM self-trust rule is that the first time the function runs, it creates the IAM role, and then it gets an ARN from AWS, and then the next time it runs, it uses that ARN to put itself in itself to trust, right? Because there's certain things in AWS that if you want to assume your own role, nowadays you actually have to give yourself, you have to trust yourself. And this is actually very difficult in a lot of other infrastructure provisioning tools, but with functions, it's very simple. And you can see here, I'm just using Go templates, and what we do here is I'm just digging it, right? So I go through that structure in Go template, I say, hey, pull out the ARN that's already in the function that I've observed, and then just drop it into the AWS permission and create it, right? And then I also have here like lists and stuff, so people could add extra principles and things like that when they're creating this, right? So in not a lot of lines of Go template code, we're creating an IAM self-trust rule. All right, be cognizant of time. Finally, the function ecosystem is growing incredibly quickly. KCL, I don't know if you know, that's a very fast-growing language for Kubernetes. There's a QLang that Elastic is using very much heavily internally. Go templating is very similar to Helm. Somebody's starting to write a PKL, Apple's new configuration language. It's an alpha, but it's going to be out pretty soon. So basically, and there people are starting to write things for context, like invoking lambdas to pull data out of DynamoDB to then to drop into your functions, right? So these are becoming very powerful, and in the future, we're actually going to have operations functions that could do things like schema migrations and things like that. That's kind of the design for them, doing operational. All right. Couple other things here. You could render functions in advance. So you could, if you're developing functions, you could actually render them yourself. Let's see here if I get, let's see, so I'm just going to put the shell script here because I have a long, but what you can see here is that I am going to render in advance. So when you're doing local development, you could just run these functions locally, right? And you could just say, hey, render what's going to come out. And what I actually do here is I provide data, the external data. I simulate the real world because I drop some YAML in there. And so this actually simulates what would happen if I ran this function in a Crossplane cluster, right? So this is part of developer experience we have. You could also validate these too. So in terms of shifting left, you could have CI pipelines that do things like render in advance, calculate diffs, validate it before it actually ever gets put to the cluster. All right. And then the last one we showed for operators, day two operations, we have metrics on almost every single object, right? So what that means is we could do things like top, and let me see here, I'll do my last thing here. All right, so what I did here is I created metrics, right? So I applied metrics to the cluster. Let me see if I can get my screen going. So right now, I didn't have metrics on the cluster before. I just applied, and what I said was I want to look at all AWS resources that are on this cluster, so I'm going to reload this. This is the Prometheus endpoint of this cluster, so I'm not using Grafana or anything funny or anything graphical. And you can see here now that basically in every single type of resource, we're going to export the metrics in real time. And this includes when it was synced, when it was ready, and everything, right? So you can imagine this, you can have real time across all your clusters, what is the status of every single resource that you have, that you're managing, right? And I don't know if anybody has anything like this, right? So metrics is getting to be a very important part of what we do. And again, you're looking at API, provisioning, drift detection, metric scalability. So like, we're really building things for like the enterprise. All right, I think I'm close on time. I'm going to finish there. The last thing I have a couple summary slides, but I just want to say, obviously, rate this slide, rate this. I really appreciate your time, and thank you very much.
Thanks to you. We are about to run out of time, but questions? We still have time for one, maybe two, if you're super fast. Raise your hand. Yeah, faster.
I'll try to be fast. All right. Okay. So towards the end, you showed some pretty advanced stuff, so this question might not be valid, but if I were to propose something like this, in my team where we use Terraform and Kubernetes, what's the top gains, would you say, it is over that setup? So how do I tell something like this to my team? Is it the constant checking of the drift over what Terraform doesn't do, or what would you say it is?
I think the operational model, right? Because you could even run, we have a Terraform provider that could take existing workspaces and run them. The operational model is just a lot better, right? Everything's CRDs. You don't have, what we see is a lot of people have their Kubernetes clusters and they have their Terraform infrastructure, whether it's shell scripts or Atlantis or something, and it's just a totally separate thing. Here you could unify it. So it's just better in terms of operations as you scale up your infrastructure team. Thank you.
Okay, there is less than a minute between us and the coffee break. Thanks again to Steven. Again, please, big applause.